Hello. Today we're going to go through the index laws. These are all the index laws. We're going to go through them one by one, and we're going to do some examples of applications for each of them. I'll put some chapters down below so you can fast forward to the ones that you may have problems with later on. Okay, so here we go. Rule number 1. Let's say we have x squared x to the fourth. So we're multiplying x squared x to the fourth. And this really means x times x times x in a bracket. This is x squared. And x to the fourth is x times x times x times x. So 4 x's. This is that. So what we end up with is we can just remove all of these brackets. Goodbye, goodbye, goodbye. And we have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. That's x to the 6th power. So what we've done, we've just added these powers together. So we've got x to the 2 plus 4. So that's rule number 1. So let's now do some examples. Let's say a cubed b squared a to the power of minus 1 b cubed, and let's have d squared e squared f to the minus 1 multiplied by d, and let's have a cubed, a squared a cubed a to the 5th b to the half and c cubed. So let's work through each of these. We're just adding the powers when we're multiplying them all together, remember? So a to the power of 3 plus a to the minus 1 is 3 minus 1, so we have a squared. B squared and b cubed multiplied together is just 2 plus 3 b to the 5th power. Now d squared multiplied by d. Well, this d really has a 1 there, but we just don't put it. A to the 1 is equal to a, d to the 1 is equal to d. So d to the power of 2 multiplied by d to the power of 1 is just d to the power of 2 plus 1, so d cubed. We have e squared, no other terms in e, so we have e squared, and f to the minus 1, f to the power of minus 1. Now this one, a squared, a cubed, a to the 5th power, we just add them all together, 2 plus 3 plus 5, so a to the 10th power. This is the only term in b, so b to the half power, and c cubed, c cubed. You'll see why I'm putting fractions and negatives in powers. As we go through these powers, they will become clearer. Okay, let's move on to the next one. Okay, rule number 2. Let's say we have a to the 6th power divided by a squared. Now, what this is a times a times a times a times a times a divided by a times a. So we can just cancel like we do with normal fractions. Cancel that, cancel that, cancel that with that, and we end up with a to the power of 4. And it's as simple as that. Very simple law. What we've done is 6 minus 2. So we take away whatever we have as the division from the numerator, and we end up with a to the 6 minus 2. Okay, let's have some examples. Let's say a to the 4th power b cubed divided by a squared b. Now, we take these variables individually, with the a's and the b's with the b's. A to the 4th power divided by a to the 2nd power is a to the 4 minus 2, so that's a squared. And the same with the b's, we have b cubed minus b to the 1 power. So it's not minus, it's divided, but we subtract the powers. So b cubed divided by b is b squared. 3 minus the power of 1 is b squared. Let's try another one. Let's say pi a squared b cubed divided by pi a b squared. So the pi's cancel out, we know that. A squared divided by a is just a. 2 minus 1 is a. B cubed divided by b squared, again 3 minus 2, we have b. And that's all that is. Okay, let's move on to law number 3. Let's say we have a cubed raised to the power of 2. What are we actually doing here? Just to understand this intuitively, when we raise something to a power of a bracketed expression, what we're actually doing is getting that bracketed expression and then multiplying it however many number of terms. So for this we would have this, and let's say for a cubed raised to the power of 4, we would have a cubed, a cubed, a cubed, and a cubed. 4 sets because we've raised it to the power of 4. So if we remember from the first rule, when we multiply things together, we just added the powers. So our rule number 3 is similar in a way. For this we have a to the 6th, because we just add 3 plus 3, a to the 6th. And for this we have a to the 12th. We just add 3 4 times, a to the 12th. So what we've actually done, we multiply these together. 3 times 4, a to the 12th, a to the 12th power. And 3 times 2 is 6, a to the 6th power. Okay, let's do some examples. Let's say a squared raised to the power of 4. Again, we just multiply these together. A to the 2 times 4, 2 times 4, oh dear, 2 times 4 is equal to a to the 8th power. Let's try another one. Let's say a cubed raised to the power of 1/3. Now obviously 3 multiplied by 1/3 is 1, so this is a. We'll get to fractional powers soon. Rule 5, 6 and 7 all deal with fractional powers. They're a little bit more complex, but you'll understand them. So let's do one more. B to the 4/5 to the power of 4/5 raised to the power of 3. This is simply 3 times 4 is 12, so b to the 12/5. And that's our answer. Now moving on to law number 4. let's consider we have AB to the power of m. Let's substitute some numbers in here for a and b. Let's say we have 2 times 3 to the power of, let's say, 2. A and m are equal for argument's sake. Now, if we follow these rules, 2 squared multiplied by 3 squared, this is equal to 4 times 9, which is equal to 36. Okay, that's easy enough to understand, but it doesn't intuitively tell us why. But if we just do this multiplication, 2 times 3 is 6. 2 times 3 is 6. 6 squared. We know what 6 squared is. It's 36. It's the same as this here. So this rule is just simply distribute this power to every number within the brackets. So if you have, for example, let's say pi squared a cubed b c to the 4th raised to the power of 3. Now this is interesting. This is where we can get messed up. Let's take these terms one by one and see what's actually happening here. Take it slowly and you won't make mistakes. We have separate terms. What we have here, let's call pi a for a moment, but a is squared. This goes back to rule number 3. So we have pi in the place of a and 2 in the place of n, and we're raising it to the 3rd power. So what we have is pi squared raised to the power of 3. So 2 multiplied by 3 is 6. So we have pi to the 6th power. Very nice. We do the same with this one. We just go in order. A cubed raised to the 3rd power is a to the 9th. B cubed, b to the power of 1, multiplied by 3 is b cubed. And c to the 4th raised to the power of 3 is c to the 12th. Okay, now we can move on to rule number 5. But before we can start, we need to be absolutely clear that we know what is meant by the root of a number. As you know, the square root of a number is a number that when squared gives the original number. So the square root of 4 is 2 or minus 2, because 2 squared is equal to 4 and negative 2 squared is equal to negative 2 multiplied by negative 2 is equal to 4. 2 negatives make a positive. So the same is also true for, let's say, a cubed root. So the cubed root of 64 is equal to 4, because when we do 4 cubed is equal to 4 times 4 times 4 is equal to 64, this original number here. And negative 4 is a cubed root of negative 64, because negative 4 multiplied by negative 4 multiplied by negative 4 is equal to negative 64. So the roots of numbers need to be fully understood before we can look at this, before we understand what we're doing with it. Now let's look at rule 5. We can relate rule 5 to rule 3. If rule 3 is to work on rule 5, then it must mean that, for example, we have, let's say 2 to the power of 5/3. Here is our fractional index, and this is equal to 2 to the power of 1/3 multiplied by 5. So what we've got here from the third rule is that we have 2 to the third power raised to the power of 5, and this third is a root, so we have the cubed root of 2 raised to the power of 5. This can also be expressed using the same law, law number 3, as 2 to the power of 5 raised to the power of a third, which is equal to the cubed root of 2 to the 5th power. So what we've actually seen here is we have killed 2 birds with 1 stone. We have used this a to the power of m divided by n, m divided by n, and the nth root of a to the m, nth root of a to the m. So we have 2 rules in one here. Isn't that nice? Now let's do some practice questions on this. Imagine we have t to the power of a half, x to the power of a third, root y to the 5th power, and x to the 5/7. And we're going to express these in the alternative form that they are currently expressed. So according to this fractional index here, we have 1/m is equal to the nth root of a. So here a is t, so we'll put t in here, and we have a root, and 1/m, m is 2, so we have simply a square root. We could put a 2 in here, but we don't normally, so this is just root t. The same applies for x to the 3rd power. We have x and a root, and this is our nth root, so it's the 3rd root, cubed root of x. Here we have y to the 5th power square rooted, so in its alternative form we can switch it over to this side and have, what is this, y to the 5th power, y to the 5th power, and this is a square root, the 2nd root, so y to the 5/2. X to the 5/7, well, we have x and a root. The denominator is the magnitude of the root, so this is the 7th root of x to the 5th power. Very nice. We can understand law 7 by looking at law 1. If we say, for example, we have 2 cubed multiplied by 2 to the -3, then by law 1 we do m plus n, 3 minus 3, is equal to 2 to the 0, which is equal to 1. As we know, any number raised to 0 is equal to 1. So what this means is 2 cubed is equal to 8, and in order for this to be equal to 1, 2 to the -3 must be equal to 1/8, because 8 times 1/8 is equal to 1. In general, any number to the -1 is equal to 1/a. In the same way, a to the -3 is equal to 1 over a cubed, the power flipped over and made positive. It's the reciprocal. Okay, we can look at some examples then. Let's try a simple one to start. Half to the power of negative 3. So we have a negative here, so what we can do is say this is half to the power of negative 1 times 3, which is also half to the power of negative 1 raised to the power of 3. This negative 1 flips this over, so we have 2 cubed, which is equal to 8. This can be unintuitive when we first see it, but the negative means we just flip these over and apply the positive power to it. 2 cubed is equal to 8. Now let's look at this one. X minus 2 to the negative 4 divided by x minus 2 squared. Now we have x minus 2 on the top and bottom, so we could just call this a if we like, and we're just doing minus 4 minus 2. So we have x minus 2 to the negative 6, minus 4 minus 2, which can also be expressed as 1 over x minus 2 to the 6th power, using this law here. Negative exponent means we just drop it down into the denominator. 1 over x minus 2 to the power of 6. Now let's look at something a little more complicated. Let's say we have x plus 3 squared over x to the 5th, all divided by x plus 3 to the negative 4. Now with this we will break it into chunks. So let's start with this as it is, x plus 3 squared over x to the 5th, x plus 3 to the negative 4, let's say 1 over x plus 3, x plus 3 to the 4th power, flipping this over because of the negative, bringing it down and making it the denominator, which is equal to x plus 3 squared over x to the 5th squared multiplied by x plus 3 to the 4th, which is equal to x plus 3 squared. Now because this is multiplied, and x plus 3 is the same base, we just add these exponents again. So it's not squared, it's 2 plus 4, which is 6, over x to the 5th, so to the 6th power. So let's finish up using all of these laws in a problem. Let's say we have x squared t cubed x, all under a cubed root, divided by y to the 7th power x raised to the 2nd power multiplied by root 8 raised to the -2 power. This looks nice. Let's see how we go. So, because this is all under a cubed root, what this is saying is we have x squared t cubed x raised to the power of a third. Remember, a root is raised to a power of that root, 1 over that root, so raised to the power of a third. This is a start. Now, y to the 7th raised to the 2nd power is, remember, we're multiplying according to rule number 3. Y to the 7th raised to the 2nd power, 7 times 2 is 14. X squared. Now, this is, we can open this out and say the root of 8 is 8. Let's put a bracket there to keep it tidy. Is 8 to the power of a half. And it's raised to the -2. -2. Now let's see where we are. Now inside here we have x squared and x, so we can call that x cubed, t cubed, all raised to the power of a third. This is going to simplify nicely for us. Y to the 14th x squared, we'll leave that alone for the time being. Y to the 14th x squared. A half multiplied by a -2 is -1, which is 8 to the -1 is just 1 over 8. So this simplifies to x to the x cubed multiplied by a third is the power of a third, is just x. 3 multiplied by a third is 1, so xt over y to the 14th x squared multiplied by an eighth. Well, we can bring this up to the top now. An eighth, the reciprocal of this, is just simply 8 in the numerator, y to the 14th x squared. Simplifying, cancelling these x's, we have 8t over y to the 14th x. And that's our solution. Isn't that beautiful? We used every single one of these rules in here to solve this. When you do it methodically, it's really quite a simple process. I hope you've enjoyed the video. If so, subscribe, like, comment and share. Bye.